Are these triangles congruent? If so, explain how you know with a flowchart. You may need to label the vertices. And then indicate a sequence of transformation that maps one triangle onto the other. If not, explain why not. So let's take a look at what we have here. I've got the single value of 8 on each of them, so I do have at least one side. And in this triangle, 30 plus 60 is 90, and because of the triangle's angle have to add up to triangles angles have to add up to 180. I know that this would have to be 90 degrees, and over here I've got the 60 and 90. This must be 30 degrees. So I can see that I definitely have the angle side angle pattern, right? 30 degrees to 8 to 90, and that's matched on the other triangle, 30 degrees, 8 long, 90 degrees. So let's go ahead and label these so that we can talk about the proof. So we're going to say we've got triangle A, I'll call this B and C, and then over here I'll label this triangle, and I'm going to mix it up. I'll label it triangle. I can't use B, I've already used that. I'll use triangle H, H, W, M. This is like as obscure as I could possibly be. Okay, so there's the triangle. So let's talk about how we could construct a flowchart proof. So at the bottom of the flowchart proof, I know that I end up getting that they are congruent using the method. I end up getting it with side angle side. So I am going to have congruent triangles, and they're going to be congruent by side angle side. I do have that the sides that are 8 are both congruent, right? I do have the sides that are 8 are both congruent. So I could put that here. The sides that are both 8 are congruent to each other. But then I have to use the triangle angle sum to figure out these missing angles, right? So I need to get that angle C is 30 degrees, and I need to get the angle W being 90. And then once I get that, then I can do the side angle side. So I know that I do need to eventually say that two of the this is too big for our purposes for this side. I know that I need to say that two of the I want to say angle B and angle W are congruent, but in order to do that I have to show that angle W is 90. So this is going to be B and W being congruent, but that's going to require that I establish that angle W is 90, and then I'm going to have one that's going to say that angle that was B and angle W, angle C and angle M are both congruent because they're both 30, but that's going to require that I establish that angle C is 30 degrees. So I think I could add more steps in here too, but I think this is a pretty decent look at what's happening, right? So this to here, and to here. I was trying to put little triangle or little angle marks, directions. There we go. And great. So this is going to be roughly our proof here, and I'm going to start with saying that we could add a lot of steps here. Like I could say, for example, that BC is the length of BC. That's where I don't put the line over it. I could say that BC, that's the length of segment BC, is 8. And I could also say that the length of segment, I'll do WM equals 8. And both of those are given. So off to the side here I'll write GIVEN, and that'll flow down to here. Now, because those angles, or because those sides are both 8 units long, I could then say that BC, segment BC, is congruent to segment WM. And those are congruent by the definition of congruent segments, right? Definition of congruent segments, which says what? It says two angles are congruent if and only if they're the same length. So we've got segments that are the same length, therefore they're congruent to each other. I don't think I'm gonna. I could do similar things with all the angles. I don't think I'm gonna do that. I'm just gonna say, I'm just gonna say this. The measure of angle C is 30 degrees, and that's because of the triangle angle sum theorem, right? Which just says the three angles in a triangle have to add up to 180. Well, if you take 180 and subtract 90 and 60, and I might write this right up here, 180 minus 90 minus 60, you definitely get 30. And the other angle is angle W. I didn't know that, so you can see I wrote it in my handwriting, but that wasn't given. So I'm going to say the measure of angle W is 90 degrees. And again, that is the triangle angle sum theorem. The three angles in any triangle add up to 180. And again, 180 minus the 30 and the 60 that we were given does equal 90. So I have here now that I've got all the angles that I need. I think. Um, Not quite. I should talk about. Actually, I need to feed in two other angles, right? So I need to say this one. I need to point out that the measure of angle B is 90 degrees, and that was given, right? They gave me that B was 90 degrees. That was on the diagram. And I also need to include that the measure of angle M was 30 degrees. So the measure of angle M was 30 degrees, and that was given. Okay, so now I think we have everything, right? So I can say that angle M is congruent to angle C, and that's the definition of congruent angles. They have the same number of degrees, therefore they're congruent. They both have 30, and I've supplied reasons why I think they're both 30. And then for the other angles, I'll say the measure of angle W, or not the measure, I'm sorry, I don't want to talk about its measurement. I want to say that angle W is congruent to angle B, and that is also the definition of congruent angles, right? They are congruent to each other because they have the same number of degrees. Then as a final step, because I've got this angle side angle established, right, I can say that triangle ABC is congruent. And let me get the right order here. I did 60 to 90 to 30, so I have to have triangle 60 is HWM. And these are congruent to each other by the ASA theorem, right? Two angles in the included side, and that is one that we did establish in class. So that's a flowchart proof for number 48. It does ask us to finish by describing a series of rigid transformations that could map one triangle onto the other. If I just spin these triangles around, the 60, the 90, and the 30 are never going to line up. So I know that I need to do a reflection. So I would say, I'll just take the triangle MW and I'll say reflect triangle MWH over, I'll just say reflected over MW, segment MW. So when I reflect it across, it becomes this triangle like this, right? So the 90 would be still here, this would be the 60, and this would be the 30. But at that point I could then do the rotation that would map them up. So then I would say, now that I've done that reflection, I'm just going to say translate M to C. Translate M to C, and that's point M to point C. And then I would just say rotate, TA, rotate until, I guess I could say rotate until BC lines up with WM, until BC and WM coincide. Because eventually if I rotate it, they'll meet up with each other. All right, so that's our flowchart proof. And I think we probably could even throw more steps in there. I think this is a good number of steps. I definitely established that angles M and C were 30 degrees. I definitely established that angles W and B were both 90 degrees. Because those angles have the same measurement, they're congruent to each other. We were given that BC and WM were equal to 8. Because they're equal to 8, they're congruent to each other. Remember, if you're given in a proof, if you're given things like this, if you see on a diagram that this is what you have, then you don't have to talk about the lengths giving you congruent things. When you see those tick marks mean they are congruent, so it immediately goes to it. Without those, we kind of need to add this extra step where we say they're the same length, therefore they are congruent to each other. All right, that's it.